In the midst of conflict, disaster, or acts of terrorism, the Army may face a deluge of information. Our ability to respond may depend on how fast we can assimilate and react to the barrage of data.
Apollo is an information distillation engine, an information refinery, if you will. It takes large amounts of crude, low-quality data and transforms it into a smaller amount of higher quality information suitable for decision making. Whenever you have a lot of data, it helps you prioritize where to look first.
Apollo is designed to work with sensor data, images, or text data. Although this demo will focus on text, more specifically microblog data. In this demo, you can see how Apollo automatically distills 2 million short messages collected from Twitter during the Egypt uprising in the week leading to the resignation of the Egyptian president. It distills them into just a few dozen key messages that tell a coherent story of the event as it evolves. It can do it retrospectively or in real time. The main value proposition is therefore to reduce the load on analysts and help point them to the most credible information. By reducing this load, we can help make better, faster, more informed decisions. The idea behind Apollo is like this. We first recognize entities and claims. We then create a logical network with links between related claims, links between related entities, and links connecting entities to their claims to represent who said what. We can think of each link as a relation or a piece of evidence. We then find the optimal assignment of truth values to entities and claims that is maximally consistent with the links in the network. That is to say, we determine what may be true and what's not in a manner that is maximally consistent with the evidence. This is an expectation maximization problem, and we use Dempster's EM algorithm to solve it. We can also compute a measure of confidence in the result using the Kramer-Rouse bound. It tells us how likely our conclusions are to be true. We have implemented and tested our algorithm on simulated datasets where we know ground truth. It was shown to outperform Bayesian estimation significantly, especially in systems where situations do not repeat often. The demo runs a simplified version of that algorithm that is optimized for speed. This capability that you see is the result of an interdisciplinary collaboration made possible by the Network Science CTA. To understand relations between claims, Apollo needs to process text or images. To understand relations between entities, it needs to process social network graphs. The idea of analyzing a graph to rank nodes itself comes from information network researchers. The idea of using the particular analysis algorithm, EM, comes from sensor networks and data fusion.
So, as our vision, we want to make Apollo as general as possible and to reduce the cost of figure out the truth. That will make the problem more complex, and we need the theory behind it, and we need the efficient way to solve it in the computer as well.